I have just done something very exciting, at least to me it is. I'm going to record my screen here because you've got to see what I did to my primes program. See, I've been working on my primes program here trying to speed it up. And so what's happened is that I'm doing a very interesting experiment. This is something I added. First of all, okay, now let me show you the old versions. Okay, yeah, like here's okay, so I had two different versions of this program, and the only difference between these two is one throws an exception with the default new and then catches that exception and sets the pointer to null and all that. The other one automatically has a null pointer and all that, but that's just memory allocation. You see, these two programs are the exact same thing. Okay, so here's the thing. The way that they worked with the code is it literally starting at 1 and going through first it sets all numbers to 0 exactly. And this is still a good idea. But what this does is it's starting at 1, it increments all multiples of that number, so it will keep increasing by 1, and every single number it is what it does basically. So it's going to cancel out everything that is prime or not. And basically, I'll show you that it works. The one with the no throw one, it absolutely works. No throw. Okay, so yeah, there is no throw. And that one there, I had it set to do all the primes less than 128. And it absolutely works, but it's a little bit redundant. And see, the way that one worked is it literally it counts how many factors every number has, and if it has exactly 2 factors, it's a prime number. However, my new program that I'm working on here, this has a different method, and what this one does is it starts out by allocating the memory the exact same way as the previous program. But what it does, it allocates the memory and sets all elements to 0. But then it does something a little bit different. What it does here is it starts at 3, and instead of increasing at 1, it increases by 2 each time, doing only the odd numbers. Okay, so obviously there's no need to go through everything and mark everything as a multiple of 1, because we already know everything is divisible by 1. What this does is it only checks odd numbers. That means that this loop is twice as fast because it will only check odd numbers, and it will go basically loop through all of them. Basically, so here's how the code down here worked. This works pretty much the same way as the other one. It's slightly different. I just changed the order of some things, but basically the current value of x, which starting is 3, next 5, what it does is it increases y by x each time, and so it marks that by incrementing that element of the array. And I'm using char variables because that works just as well as anything else. So the way it currently does is I'll show you first. I'll show you the results. I'm going to run the program. Let me make sure my recorder is working. Okay, yeah, my recorder is working. I'm going to go back to this program. See what this does, you'll notice something. It marks 6, 9, it marks 10. See, because the ones that you see a 1 or a 2, that's because they're a multiple of another number. So because 3 and 7, both the odd, it only checks for odd numbers. So because 3 times 7, which means 21 has factors of 3 and 7, it gets 2. So all of these are 1s or 2s, and then some are 0s. Some of them are 0s because they're odd numbers and they haven't been checked because I completely skipped doing multiples of 2. What's the point? Because it's very easy to avoid multiples of 2. And we know that multiples of 2 are not prime anyway. Only 2 itself is. So you see something there, but I'm going to show you something else. This little command I put here that I commented out is where it sets the x element of the array named A to 99. So I'm going to show you something. After I uncomment that and then I run the program again, notice something. Only the prime numbers here are set to 99. So we got 3, 5, 7, 9 is still 1. It was not set. 11, 13, 17, 19, 23, 29, and 31. Those are all the prime numbers except for 2 because I haven't added 2 yet specifically. Okay, so here's the thing. Basically, the reason that it skipped 9 and it skipped like some of these other numbers. So see, it goes through all odd numbers, but it skipped. Notice that it skipped 9, and notice that it also skipped 15. And the reason for that is because in the code here, you'll see I added an extra loop, a very tiny loop. If the x element of A, of this array, x element of this array named A, is greater than 0 because it increments through the for loop by 2 each time. So when it gets to the next element of the array, the next odd number, it does a loop. And while the current x element is greater than 0, it simply adds 2 again, meaning it will keep skipping all numbers that have already been crossed out as being composite, being a multiple of another number. So here's the brilliance of this. I have ways, and also, just for fun, since I still have this comment here, I'm going to, this is old code from the old program, and it may still be useful. That one, notice something. See, that one only does the ones that have exactly 2 factors. Exactly 2 factors. So 15 had 2, and 21 had 2, and 30 had 2. So that's why it shows up. So, but this code isn't actually needed. In fact, I'm going to show you something. I'm going to remove those comments. I'm going to just move them outside of the loop. I'll keep them in the source file for now, in case I ever need to use part of their code for something in the future. But here's what I'll do. Notice now there's only one printf statement. So if I run the program without the printf, well, actually there's more than one, because notice there's a printf statement that outputs the pointer, and that's pretty much all it does. Because it's simply for helping me see if it will show 0 if it's a null pointer, if something went wrong. So that besides that printf, there's this one here. So here's basically how it's going to work. I'm going to enable this printf statement, and what you'll see is because it always skips to the next odd numbered element that has not been increased, then if I print x at that specific point, I'll show you again. This specific point in the array after this loop. In fact, any time between this loop and this other loop, it pretty much. Oh, I just realized something. I don't think the location matters very much as long as it is after that loop there. So even if I remove the printf statement down there, it still works. The only way that it would not work and is if I put the printf statement up here. Wait, oops, wrong window. Okay, when I do that, it does display 9 and it does display 15 because the code, the loop that skipped them, happened after the printing. However, I'm going to do a little bit of Control Z. What you see here is, as long as the printf statement is after that while loop, that little extra while loop I added to skip all odd numbers that have been touched before by the other loop, then you see what it does. In fact, this code here isn't even needed. I don't even need that code because I'm not going to be displaying the element of the array itself as long as it's increased. So I can remove that code and I can make this look a little pretty. I'm going to, okay, so it's like this. Okay, I hope I don't run out of time before I have to go to work. I have to leave here by no later than 9:20. Okay, so here's the thing. Okay, so this code should be perfect. It should only display prime numbers. I can't imagine how it could go wrong because I've checked this extensively. So you see now when I run this program, it only shows the prime numbers. So I'm going to do something. I'm going to do a little bit of an experiment. Okay, so what we're going to do here is in this file, I'm going to see, hey, I know, okay, I'm going to set this to 1 million. Okay, I'm setting the length to 1 million, and that will cause it to allocate 1,000,000 bytes of memory and find all prime numbers less than 1 million. Let's see it go. Segmentation fault. That's weird. Wait a minute. Segmentation fault. Oh man, there is an error in my program. Oh crap. Wait a minute. Wait a minute. Oh. I think I know what might cause it to happen because it allocated the array just fine. Okay, but I think I know why it causes segmentation fault. Okay. So what I'm going to do is I think I know what's wrong. Because x got incremented, because normally this loop checks to see if x is less than the length of the array. And so the loop ends as soon as x exceeds the length, basically. If it's greater than or equal to that length, then the loop ends. But because x gets incremented here, in this other loop, ooh, I need to modify this. Okay, I could do while a to, okay, if I do that loop and then put an and symbol there, and x is, okay, actually I have an idea. I'm going to leave that loop as is, and then what I'm going to do is I'm going to add a little bit of extra code. If, okay, so if x is greater than or equal to length, then I will, okay, then it will break. Okay. Okay, so let's see what happens here. So, if x ever, okay, let's see. Yeah, I don't know. Let me see if it works. Because there's a bug in my program here. So let's see here. Oh, I'm still getting a segmentation fault. Wait a minute. Wait a minute. Oh crap, I realized something. Wait a minute here. Something here is weird. Oh, I think I know what's going on. I think I figured something out here. Because y gets incremented here before, okay, so y got incremented there before before it, okay, it needs to increment it, but it needs to make sure that it increments y, but then it always checks within that loop of, okay, so let me remove this because the issue is whether x exceeds length or not. Okay, let me see if that fixes it. Programming involves a lot of debugging. What? Whoa. Wait a minute. This seems to be... Wait, this is greater than 1 million. Wait a minute. We're over 3 million. We're almost 4 million. Wait a minute. How many zeros did I put here? Oh, there are 7 zeros. No wonder it's going so long. Okay, so yeah, that's what was wrong. Okay, so I had too many zeros. I'm just trying to do up to 1 million. Okay, so Oh, I see how it works. Okay, wait a minute. Wait a minute. And yet it's not supposed to... Oh, I see. I think I see what's going on here. Okay, so see, because it skips and does odd numbers, notice what it does here. Okay, yeah, this is freaky. So, and even if I do a break statement here, yeah, testing is important. Let's see here. Yeah, see, the break statement occurs after the print. However, this thing here, okay, yeah, I see. So basically, the way that this will work is to avoid printing. Okay, so if I put this little thing here, so it will not print if, okay, it'll break out of the loop if x ever exceeds or is equal to the length. So let me see here. Let me run this again, because, I mean, it shouldn't make that much difference, and yet it's very weird. So now, yeah, see how that works? Okay, so now, yeah, it did that. So let me compare one more time. See here, and so, but even if I remove that, let's see here. Yeah, okay, so not 4 9s and then 8 3 is the last one. So it's not supposed to print. Okay, so basically, yeah, so that's what it will do, is it will increment that. Okay, so I think it works. Okay, so I think this program works. I think everything has got worked out now. So it will break as soon as x becomes greater than the length. Okay, so there still may be more debugging I need to do with this program if there's anything else wrong with it, although I certainly hope there isn't. There's probably a way to further optimize this that I haven't thought of, but let me do one final test. I'm going to do that command which compiles and runs the program, but I'm also going to precede it with the time command. So it compiles and then it runs it. Well, that's weird. Wait a minute. Oh, I know what to do. If I do time A, oh yeah, time A. Yeah, because it was executing more than one command. Whoa. Real time is 3.660s. Oh, sweet. In less than 4 seconds, my program calculates all prime numbers. It displays all prime numbers less than 1 million. Except it doesn't display 2. Okay, I'll just have to add a printf statement for 2 specifically. Not a big deal. Okay, I'm going to just, for further testing, I'm going to just set this back to 32. Okay, alright, I know what to do. Time to end this video. I hope you've enjoyed. Bye.